Today we will be finding the relative minimum or relative maximum of a polynomial function. The relative minimum, or maximum, is the value of the function at an up to down turning point. So if we look at the picture on the left, the relative maximum, notice we go up and then to down turning point. This is the relative max. A relative minimum is the value of the function at a down to up turning point. So if we're going down and we turn back to up, this point where this occurs is called the relative minimum. Now, occasionally we will have, if we look at the picture on the right, we'll notice we have both left and right go down to negative infinity for y. So this turning point up here is a relative max. This here is a relative min. And this one here is called an absolute max because it is there's no other point higher than it. So if we looked at our first example, it says what is the relative maximum and minimum of the function y equals x cubed plus 3x squared minus 24x. In order for us to do these, we're going to use a graphing calculator. So you want to make sure you snag a yellow calculator. The first thing you will do on the yellow calculator is you will find this button. It is the y equals button. Okay, so the y equals button is located here. Okay, so you'll push that y equals button, and where it says y1, you'll type in x to the third plus 3x squared minus 24x. I got a typo here. There's not supposed to be that x there. Okay, so if you are looking for the x button is the one next to the green alpha. It is the x comma t comma theta comma n. And of course you'll do caret 3 plus 3 again, x squared minus 24x. Step 1. Next, you'll push the zoom button. The zoom button is located here in the top middle, and you want to select option 6 for standard. When we look at our graph, notice we cannot see the relative maximum or the relative minimum. We're stuck. So what we can do is we can manipulate our window. The window button is located here in between zoom and y equals. Now, if we look at the graph, notice that the y min and y max are not large enough. So what I would do is, by looking at it, I'm going to change my y min to negative 20 and my y max to 20 and push graph again and see if that helps. The graph button is located here in the top right. So once we push the graph button, see how it's red? We notice that we still can't see the relative min and max. So let's adjust the window some more. This time, because I tried several things, we're going to adjust the window to a y minimum of negative 30 and a y max of 100, and now we're going to push the graph button. Now we can distinctly see the y, or the relative maximum, and the relative minimum. So now let's figure out how to find those values. The next thing we need to do is we need to push the second button. So you'll want to push second trace. Okay, so the trace button is red in this picture. It is located here. And it should pull up this menu that says value 0 minimum maximum. We are going to choose minimum option number 3. And when you do so, notice you will have this thing on the screen that says left bound, and right bound. So our relative minimum is located around this cusp here. And the left bound, there should be a blinking dot. Our blinking dot is here. Right? Let's see if I can zoom in. You can see better. Okay, so you see how we have a blinking dot around here? We want it just to the left of the relative minimum, and then we're going to push enter. The next blinking dot, if we look at our picture, we want it to be to the right of the relative min, and then we'll push enter here. After we push enter on the right bound, it'll say guess. You'll want to push enter again to get the relative min. So how we will phrase this is we will say relative min, relative min of the y value -28 when x equals 2. Next we'll push second pencil, second trace again to get calc, and this time we want to select option for maximum. Just like before, we'll see a blinking dot. Remember, you want to do the left bound first, and in this case it looks like I've already pushed enter here, and you should see that arrow before you do your right bound. Remember, the right bound blinking dot needs to be just to the right of the relative max, and you'll push enter. Next it will ask you for a guess. You'll push enter again here. Take a few minutes to try this example you tried. What are the relative min and max of this function? Hopefully you find a relative min of -2 when x is approximately 0.64 and a relative max of 3.13 when x is approximately -0.86. In our last example, we have a designer wants to make a rectangular prism box with maximum volume while keeping the sum of its length, width, and height of 12 inches. The length must be 3 times the height. What should each dimension be? So notice we have some steps already laid out for us. The first thing we will do is we will define the variable. And for this case, for our first step, I'm going to say we know that we have words regarding height, length, and width. Okay, we are going to call x the height of the box. Okay. In step 2, we have some clues. So notice the sum of the length, width, and height is 12 inches. Okay. So that means if we were to take all of them and add them together, we would get 12. Notice that we also know that the length must be 3 times the height. So we can say length equals 3x. And what should each dimension be? Well, if we know x is the height and we know the sum of the 3, then that means our width is equal to 12 minus 3x, which is our length, minus the height of our box, which is x, or the width is equal to 12 minus 4x. Okay, and now we have enough information to do step number 3, which is model the volume. Remember, if you're given a rectangular prism looks something like this, right? And we know the height is x, we know the length is 3x, and we know the width is 12 minus 4x. Remember, to find the volume of a rectangular prism, you will multiply the length times the width times the height. So for step 3, we know we're going to have V equals 3x times 12 minus 3x times x. Because remember, we have to have the length times width times height. When we simplify this, we do get our volume to equal 36x minus 9x squared. Oh, snappy, I have a boo-boo. Okay, now that it's fixed, remember the width is 12 minus 4x. And so when we distribute 3x through the binomial, we get 36x minus 12x squared, or our volume is equal to 36x squared minus 12x cubed. So our question says, what should each dimension be? Okay, and then notice it says we want to make a rectangular prism both with maximum volume. So this is where we can go over to our graph to determine the maximum value. So remember, to graph, the first thing you'll do is you'll find the y equals button, and you will type in the function negative 12x cubed plus 36x squared. Okay, and then when you hit graph, you'll have to adjust your window. And remember, we want to find the maximum. So we're going to use the maximum feature. So you would push the second button, trace. And you want to select, I think it's option 4, max. Remember, you have to have the blinking black dot to the left of the maximum, and then just to the right, push enter for guess, and it should give you this as your maximum. So our answer is, for step 4, max volume equals 48 when x equals 2 inches. So our question says, now we're going to find each dimension. So we know x is height, because we already have defined that. So the height is 2 inches. We know that the length is 3 times x. So if we have 3 times 2, that would be 6 inches. And the width is 12 minus 4x. So 12 minus 4 times 2. Okay, so that would be 4 inches. So these values are our answer. Dun, 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 dun. We finished. You can work on the polynomial review. A word of the wise, I did change some problems, so make sure you check your key on Schoology. The end.